to start with. If you were to do yourself, you will probably be searching for those nuts. I live in a matriculated world. What I meant is, we use the standard full-fledged millimeter metric system in all our engineering practices. In our case, we use only metric threads. Metric threads have certain proportions which are probably not the same as used elsewhere in the world, including I do not know, the only thing that I can think of is probably the US, which uses unified national UN threads. Some of them come under UNF, some of them come under UNC. But you should remember, only the thread pitch designations are generally standardized, and a very large variety of nut dimensions are also available, including height of the nut. In the case of this, if you see, nominal pitch is M3, and then the length, I am sorry, I do not know why the length, I will call it a height. Height is 2.4 millimeters. If you go back and check, things varying a little above and below are also available. And then very critical thing is the size across flats here. You see here, it has been well adjusted such that the size across flat sits here. And occasionally, instead of just a single nut, you have a tapped flat. The same thing, you have a rectangular tapped flat which has threads which are tapped inside. So, once you push it inside, you can assemble things wherever you want. It is a little more convenient compared to going around, looking for where the nut is placed. Again, positive is, we know very well our well known, I do not know, maybe misattributed Murphy's law. After having got everything correct, if one nut cannot be found, you are back where you have started. In those conditions, probably, they position the nuts using a fixture of some sort. You understood it? Looks a little like the plate, whatever plate you want to mount and all that. And inside that all the material is removed, this is recessed. So, using this you can push the nuts into the proper places you want. And it is not optimum if your printed circuit board is like this. It is very rarely optimum just to stick 4 holes in the corners. It is a reasonably good practice. In reality, it is a little suboptimum. There is what are called the airy points, which will make the overall bending minimum, the maximum bending will be the minimum. In the case of aerospace components and all that, they just generally maintain 0.6 to 0.8 in this direction of the total length of the PCB, similarly 0.6 to 0.8 of the width of the PCB, and have those fasteners assembled somewhere here. In those places, an additional adapter plate may be required for you to hold that thing together. So, there is a very positive thing about it. In the unlikely case of a drop or something, and if the corner shock absorbers or those elastomer mounts take part of the shock, still the total amount of bending that can take place will be the minimum possible if you mount how to things properly. So, if you see the people in the aircraft or especially the spacecraft industry, they do tremendous amount of simulation and actual field testing for that. Stacks of printed circuit boards, after they are mounted, they are all subjected to military grade tests, environmental tests, which one of them includes giving a quarter sine wave shock and then also searching out for any resonances using a strobe. So, if you were to do all that, life is not easy. That is all I just wanted to tell. So, is here further, kindly be patient with me as to why I keep repeating or reading from here. In between, I have pointed out some things to you which are not included directly in the catalog, but the ones you start making, you will appreciate that you know why now they use this. Instead of calling it standard, or it is not a norm, it is not a something accepted by the industry as something written and all that, but then engineering has gone into it tremendously. One small caution is, while at the bottom all this large number of EXPE, some all these numbers and all that which are there are not readily available in stock. So, probably you have to start with a drawing, try to understand how well it is, and then in one of the subsequent lectures I will probably put you onto a CAD what you call exercise, by which you will be able to appreciate why drawings which are supplied with this are very, very useful. In case you cannot get the DXF, IGS or STL files for these things, STL normally nobody gives, either they give a PDF or they give a DXF, or occasionally they give the IGS files with it. You can use the IGS files, and all the dimensions, everything which are given here can easily be taken from here. One thing which has not been mentioned is there are no tolerances that are listed against it. Elsewhere in the document you will probably find it. Usually this is only a what you call a trade catalog by which you need to start your design. But once you get all this information, you can now get the actual things which is very, very critical about tolerances and all these dimensions. They have just like that very conveniently they have given opening A by B. A by B looks 72 by 47, okay with me, 130 by 80. But we need to now work out about the panel. You have seen this, minor variation is there. There is a frame and there is a panel which sits on it. There is another panel which will fully molded in a single piece. This is, for some of you people who are not very familiar, this is standard engineering practice of giving a half section view. So, the top portion of it shows how it would look when you look at it from because of its symmetry, when you look at it from here and how it looks. Bottom portion of it shows very, very critical detail which I am happy to point out to you. Have you seen it? So, this it could be ABS, as I said, variants of it, no, but everything has been adjusted carefully. You see this beautiful extra small projection which is there. So, if you are to use the standard fasteners which have come with it, including the hexagon headed or Allen screw with it, it ensures a perfect watertight assembly. So, all you need to do is carefully follow a sequence, assemble all the top and bottom parts together, and then apply sufficient clamping force so that both the top and bottom are exactly clamped like this. You clamp both of the parts together, you understood? See, there is a bottom, there is a top, exact force you apply and then put the two end caps and then tighten the Allen screws. Almost 99.99% of it will become absolutely waterproof. Occasionally there are tests carried out after this assembly, usually in the process condition, to make sure that leakage does not occur. So, obviously one of the easiest way of checking it is assemble the whole thing when it is cold, so that cold air is inside, and then maybe you can even fill it with air taken from there. After that, immerse it in warm distilled water, which is maybe 80 or 90 degrees. Things start expanding inside, and then in case there is any leakage, you will probably see small air bubbles escaping out. This is not actually destructive or anything, it is just to maintain the process parameters what you need to do. Probably elsewhere in the document they have given you about the gasketing lubricant or gasketing grease that has to be assembled, that has to be applied before assembly of this. I will check in the, both of us, let us check the actual assembly practice. So, see here, there is a beautiful panel here which you can probably carry out all the machining, and then you see here most important is EMC shielding fabric over foam gasket. Okay. What looked very simple, and it is just a what you call what looked like a rubber beading is not just that much. You also have variants of the braided gasket which you need to install in it, and then you see this small thing. One of them is it is made with some material TPE, I am not able to recollect exactly what it is. It is a 2.5 mm diameter, and it comes in a long length of half a meter. So, unit is probably the whole thing carefully made into one loop. Very rarely they make it continuous loops, or if you buy it in a bunch, it comes in a tube with so many of them. Carefully remove it, and generally people lay it out with the specified, as I said, in this case it is easy to lay and then trim it to the correct length, so that the top and bottom are fully in contact, and then it also makes contact with the front and other thing. You see here, while that is that shielded gasket with the braid, you have also the standard silicone rubber gasket, except that this comes in a meter length, and then you see here length tolerance they have given. How can it be 10%? So, if you buy a meter, is it likely that you get only 900 millimeters? It varies because of the force applied, and probably slightly also in the some environmental conditions, but I have no experience on it. You see the advantage? This is not directly related to the packaging which I was talking about. However, most people also give you their own versions of panels. So, if you can standardize your things like printing, embossing die by new manufacturing process, all of them are invariably available from the manufacturer. So, those of you who are likely to get into this engineering field, you can offer it as a design practice. This is a matter of, because I do not have it, we have my colleagues who often do this manually, because we work in very small numbers, maybe a batch of 10 or anything. So, you see here now, just like you have your vinyl cutting machines, you have machines which do all these things. See here, beautiful machining on enclosures is taking place, and then you have a large number of beautiful enclosures which are designed by you, manufactured by you. You can even what you call take a design registration, and the most manufacturers, they will respect your other things. Now you see, while the part about putting all this on the front and all that is reasonable, what is extremely difficult for a small design house to work on is, see here, the beautiful openings and a little bit of that masking for input output devices, also the connectors, which is important, absolutely important. You see here, so beautiful, they may be gland nuts, so you may have a collet, you may have a rubber packing or grommets, and everything fits and 100% reproducible. So this is life as it should be made. So I will again go back to the beginning of the you have seen, you have stuff with end gaskets, and then material can be all this. So many variants of these are available. Life is, it's a question of very carefully getting prepared upfront for making your design in place. So this is a matter of detail, high quality printing and all that. This looks, I think you need not worry too much about it. So anything you want is already included in this. Otherwise, you see here, even the way the whole thing is held together, reproducibility is typically 100%. Now you have one more small bit of detailing. In the video which I have pointed out, we have shown you a small almost like a tabletop CNC machine, which is actually an engraver, X and Y it has, and then also there is a Z attachment, Z or Z attachment, plus there is a rotary attachment. Using this, things like this, all sorts of engraving operations and things to make them very, very professional is done. While all that inkjet and all is okay still under relatively benign atmospheres. Benign means there is no scrubbing operation on top of it, not operated frequently, only occasional cases, or it is covered only when required. Somebody needs to open it and then they try to do everything and it gets closed. In regular long term use and lightly more harsh environments, engraving is the preferred way. And then we also have now paint filling. So in this case there is a small needle which is dispensing the correct paint, which eventually probably will dry up on atmosphere. It's a anaerobic type of thing. After you do it, either it kept in another accelerating with some catalyst thing, and then everything hardens up. Eventually you will have a thick seal which is scrub and waterproof by itself, and in the unlikely case that little paint falls out, you can always fill it back. Now these days laser cutting and all these things are also available, but then you will notice that it probably makes sense only for very large dimensions. One small detail I had forgotten to point out at that thing earlier, and since we still have a little more time left, you see the way the overlap and the way the end cap is fitted here. This is the detail which I had taken forward and brought you back to show this here. In this corner you will see that this material also sits here, and then your Allen screw sits flush with it, and probably sufficient arrangements have been made, and especially with the provided tool, if you apply the correct amount of torque, and then probably enough stoppers and all are available here, and you see the gentle slope is there here, gentle slope. So the gasket that sits here sits flush against it, and eventually the whole thing sits neat, extremely neat and flush. So under most conditions it lives to the promise of the IP65 which they are talking about. So my own what do you call, I am sure it is solicited advice only, that you start with it, and even where you feel it is likely to be not exposed to these extreme things and all that, at least the first one or two pieces which go to the field for testing, you probably need to use one of these enclosures. That is what we have been doing for a long time. If you remember, I have been showing you some boxes and all right from the beginning, including an aluminum, what do you call, straight away bought box from outside, including a polycarbonate and other including ABS enclosure. We start most of our things with that, because overall we have found out things fall cheap, and if you scout around, even in case, in the unlikely case that you run short of quick supply of these materials, generally they about fall into the same shapes and sizes and all that. If not the person you have started with, there are other alternate manufacturers who try to give us these materials. You see, practically anything you want is probably available. Okay. So I think I will stop here, again with the standard acknowledgement that you have seen this here, including all sorts of any small slopes, all of them can be taken care of. And then of course CNC machining these days, this is where why that particular CNC machining and engraving have been included is, in case you use any package, there are standard packages, and then use it for the case of your design, you can easily extract by using that layer or overlay techniques dimensions that can be required for all your machining operations in all three planes, that is XY, XZ and YZ planes. And then if you extract it and then pass it on to the supplier, generally suppliers will help in accepting this, convert it to G codes, which machines use for making all these things. So the whole thing, just like on the electronic side, you have automation. Generally when they talk about EDA tools, they talk about the schematic capture and probably making a rat's nest, and also a little bit of arranging and eventually routing, and then multi-level. Even I have seen some PCBs made here by our students, and designed up to 8 layers, no problem. But conventionally it is much easier to work about double sided PCBs and then probably stack them together through a pre-preg or something, and the file that was used for making the PCB, especially the mounting holes, and in case you have any heat bridges, there are some active heat producing components. Most thing I can imagine is probably a power transistor, or all of you must be familiar with the 3-terminal regulator, 7915 for the negative and 7815 for the positive output. All these come in that small flat package with a heat sink metallic portion on this. So, that details from that PCB EDA software can always be transferred here, and it can be used here for carrying out all the operations here. So, directly if you see the example here, you see here very neatly some operation is being carried out, all to accommodate another printed circuit board which probably has these keys here. Looking a little at these openings, I can only make a guess. Probably it is made for some connector which comes out, and then the two flat things and a circular thing typically could be a BNC or TNC or something at the back. So, you assemble it from the top and apply sufficient torque and what do you call, assemble the whole piece. It works like a charm all the time, and if you use the same file which are used for laying out the PCB, most packages can understand the features. So, if you work with the what do you call, in connection with packaging people like us, we now have something which fits usually at the first time. So, it is a good starting point. Have a concept. If I remember in the beginning I told you that we need to probably make a cardboard model. It is easy to make a cardboard model because you have the external dimensions, and then you have two choices. One of them is, if you want to try a one first piece, you can probably go to the our fabrication place and then attempt to convert this concept into a small enclosure with all the necessary thing about notching and how the thing joined together, about bending elements, and there is a very elaborate lecture on the fastening techniques that it is used. If I just list out something or show you from the catalog, it is not quite the same. I will try to bring a few of the pieces and then see if best we can make a setup saying this is how something called a riveting stud is used. So, if you are curious, just check on the internet and you will get multiple hits about the type of fasteners that are used and the way you assemble things together. So, allow me to end this session here. Thank you, and I will call it a self improvement exercise. So, what you do is look around anything you have with you. I was just thinking about, because I found this a wireless mouse, why can't you use this wireless mouse and then see how well. I am sure you have enough of these not so great working things. Open it, look for various parts inside, and then if you are a lucky person like us, I am sure you have enough floppy drives and probably partly damaged hard drives, open one of them and then have a look at how things have been packaged. One of the first thing you will notice is very rarely it is a simple rectangular PCB. There will be large openings inside, often they are asymmetrical, and then whole thing can be put together. So, it is probably a good time for you know to look into your junkyard and pick out some equipment, and I am sure several of you probably have some damaged electronic stuff at home. Have a look at them inside. And then why I insisted about this is you can make absolutely watertight equipment by taking things off the shelf, and then the failure will not be because of the packaging. The failure may be because something related to stress or unexpected electrical inputs. In the parts where I live, electricity or mains voltage varies tremendously, and even so called accumulator batteries, the voltage is not that stable. Even if you take a normal lithium ion stuff which you can find inside your mobile, nominal is 3.7 volts, but then when it draws a heavy current, it dips. Other extreme, when charging, the voltage sometimes goes above 4.2 volts. So, you have a wide variation from 3.5 volts to 4.5 volts. These cause damage. So, thank you. Please stick with us, and then tomorrow I will try to show you a catalog of some other things. So, thank you.